Now let's look at the dynamic EQ module. I guess the first question might be, what is dynamic EQ? Think of dynamic EQ as an intelligent EQ. Normally, EQ is set up to cut or boost frequencies, to tonally balance a mix, or fit an instrument into its own sonic space within a mix. This is fine for most users, but what if we have a set of very loud or quiet frequencies within a mix? Yes, we could set up a severe EQ cut or boost that deals with those, but that setting then affects the rest of the mix. We could use automation, but this is where dynamic EQ comes in. You could almost think of it as an automated EQ. If any frequencies exceed a preset threshold, they are compressed or boosted as required, adjusting dynamically, hence the name dynamic EQ. Let's take a look. At first glance, the interface is very similar to the EQ module that we looked at earlier. The main spectrum view at the top has 6 nodes, one for each band. Click-drag these left or right to adjust frequency, or up-down to adjust gain. The handles that appear on the current selected node can be dragged in or out to adjust the Q setting. Changes are reflected in the parameter and filter display beneath, and they can also be adjusted here by click-dragging up or down, or to manually enter a figure, double-click over the text display. Like many other modules, this can operate in either stereo or in mid-side mode. These control and filter options are identical for each band, which each have their own tab. Click on a tab to switch to that band, and the band can also be turned off. Click on the on-off switch on the band's tab to do that. Each band has a choice of digital or analog processing for the filters. Analog uses minimal phase filters, which are suitable for most users. Digital uses linear phase filters, which preserve the phase of material, but uses more processing power as a result. The filter choices here are the same peak types as found in the regular EQ module. These are the most useful for the type of processing this module is designed for. There's also a high and low Baxandall shelf type filter. The dynamic element of the processor is found to the right. Here is where a band's threshold is set. Drag the slider up or down the meter as required, or double click on the parameter text display to enter a figure directly. Attack, that's the time a compressor waits before applying the gain reduction, is also set here in milliseconds. The time that the compressor waits before releasing the gain reduction once the output level has dropped beneath the input level is set here, also in milliseconds. Auto scale is enabled when lit. This allows Ozone to automatically scale the attack and release times based on frequency. Inverse mode allows the band to act more like an expander, increasing gain once the threshold is crossed. An arrow on each node indicates whether that band is currently set up to compress, in which case a down arrow is displayed, or expanded, in which case an up arrow is displayed instead. Let's look at a practical example to help explain its use. I'm going to look at 4 scenarios, each involving the snare drum. These are just for demonstration purposes to amplify the effect, so settings are more extreme than might be needed. In the first instance, I'm going to boost just the snare drum every time it sounds. We need expansion on just the snare to do that. You can hear that in use here as I've set this band to enhance the body of the snare. I've tuned the frequency setting to where the sound of the snare body is most prominent, and I've set the gain to around 5 decibels with a reasonably fast attack time, and switched on inverse mode. Now every time the snare plays, it is boosted. You can hear that as I turn the band off and the snare drops back down into the mix. Watch the spectrum display and see the boost indicated in time with the snare. In a second scenario, I'm boosting frequencies around the snare, but this time compressing the actual snare hits. To do that, I've just turned inverse mode off. The frequencies covered by the filter settings are now boosted almost continuously, but the snare is compressed slightly as its level crosses the threshold. Again, this is visible in the meters. You can see the expansion in the threshold meter as well as the spectrum view. Also in the spectrum view, you can see the snare being compressed every time it sounds. In the third scenario, I want to cut frequencies around the snare, but not cut the snare quite as much. This time I've set up a cut around the snare frequencies by reducing gain and switched on inverse mode. The frequencies around the snare are now being compressed, but every time the snare crosses the threshold setting, the gain reduction is lifted slightly, allowing more of the snare through. The band is now acting more like a gate. Finally, to compress just the snare frequencies every time it sounds, I simply turn inverse mode off. Now, as you can see in here, gain reduction is only applied when the snare sounds. And that's the Dynamics EQ module.